hope everyone who submitted questions are here tonight. Maybe while we wait, you can put in the chat, how is your studying going from a 1 to 10, on a scale from 1 to 10? How is studying for maths going? And on a scale from 1 to 10, how's your nerves for Friday? Who's going to kick us off? Atenkosi, how's your studies from 1 to 10? And how's your nerves from 1 to 10? Good stuff. 8 out of 10. That's nice. Michaela, how's your studies going? Nerves, 5 out of 10. Hi, Sayuri. Welcome. Nerves, 10 out of 10. I know some of you attended the study skills workshop, and Nicola taught you some deep belly breathing and some ways to calm yourself. So now is definitely the time to do that deep belly breathing and just those, what did she say about the aroma oils, all of that. Nerves, 8 out of 10. Yeah, it is nerve-wracking, no doubt. But you guys have got this. You've been coming to these sessions, you've been working through papers. So just trust in what you have been doing. Just trust that, and you will be fine. Okay, I'm going to kick off. It's 1 minute past, and like I said, we've got a lot to get through. We've got questions here tonight from Christian, Hamed, I hope I'm saying that right. I've got Karabu's question. I've got a question from Sayuri. And yeah, we'll see how far we get, because there are quite a few. Now, Coco, is Christian here? Christian, let me see if he's in the list.
Not quite yet, but he's normally here. He should join in a few minutes, I hope.
Okay, so I'm gonna wait with Christian's question just in case he shows up tonight, and I'm sure he will. And in the meantime, everyone can have a look at Hamid's question. Is Hamid here?
He's not here either, I'm afraid.
Okay. Well, Karabu is here, right? I think I did see Karabu.
Yes, Karabu is here.
Okay,
yes.
Karabu, we are rolling right ahead to your question. There we go. So everyone have a read through so long. What is nice, I think, about tonight's session is that we are tackling some harder problems. We are tackling that problem-solving stuff that sometimes you look at and you go, oh, I don't know. And sometimes it just takes a little bit of fiddling, a little bit of playing around. And it's good that we get a chance to talk about what we do when we don't know what to do. So we'll definitely get a chance to practice some of that. But have a look so long at Karabu's question. Karabu, maybe you can tell us what paper this is from, or if it's just somewhere.
It's from the prelim 2020 paper.
Okay,
from the
cool.
prelims, yes. Oh, yeah.
Okay, great. Thanks so much. Now, I believe in last night's session, you did do a bit of sigma notation. So that'll be a good, this will be a good question for you to maybe consolidate some of what you did last night with Lee. Lee will be back tomorrow night for your last session. And I hope tomorrow night, after you had your session with Lee, you're just going to go to bed. Go, you are talking, but you are muted. I hope you know that. Unless you don't want us to hear what you're saying.
No, I want to say, ma'am, your Bitmojis are on fire tonight. I'm loving all of them. They're cracking me up.
I quite like the owl, given that it's just been Halloween.
Yeah, it's really cool.
I don't know if it would have been my first choice of outfit, but it's sweet, the owl. I think the owl must be our mascot.
I agree. Absolutely. It's either you or Miss Clausen. The grade 7 teacher has a banana head. We love it. Love it. That's the funniest thing.
Yeah, so I think the grade 7s can have the banana, the grade 12s can have the owl, and we'll see what the other grades come up with. Okay, so we've got here, given the series 1 plus 2 plus 3 plus 4, etc., all the way up to 5,000, write the series in sigma notation if all the powers of 4 are removed from the series. Now, if we are going to remove something, we are going to, in other words, if we put that in a mathematical operation, that is subtracting. So we might think that, okay, I need to take out all the powers of 4 and think what they would be, and that would be a good thought. But let's start there and say, okay, here's 1, 2, 3, 4, 5, 6, all the way up to 5,000, and you have to write in sigma notation all the series if you remove all the powers of 4. So the powers of 4. And this is again, I want to talk a bit more about what do we do when we don't know what to do, because this is definitely not a routine standard type question. It's a kind of question that you have to think. Okay, so hi Zwelihle, good to see you. Hi Timothy, everyone's here, well done. So my suggestion with these kinds of questions is always just start somewhere. And normally when you start somewhere, you'll see that, you know, things start to reveal themselves, and you as you think through the problem, you start to see some connections, you start making some connections, and you start putting the pieces of the puzzle together, because that's all this really is solving a puzzle. So the powers of 4, I would say, I'm just going to scribble that a bit better. It's my handwriting. Powers of 4. Now the powers of 4 will be 4 to the power of 1, 4 to the power of 2, 4 to the power of 3, and so on. But only up to 5,000. So we can't go past 5,000 with the powers of 4. So any number in this series that's a power of 4 has to be removed. Removed is the same as subtract. Okay. Sigma notation. Now, what do I need for a sigma notation? For a sigma notation, I'm just going to make a big sigma here. I hope you guys are practicing your sigma so that you can just zip them up on Friday like it's nothing. Okay, so it always has to have a starting point. That's at the bottom of the sigma. An end point. I'm going to start somewhere and I'm going to end somewhere with adding these terms together. And here you always put your general rule, or the general term for your series. So we basically, what we've got here is we're working with 2 series. We're working with this one that's 1 plus 2 plus 3 plus 4 plus da, 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 all the way up to 5,000. And we're going to take away from it the powers of 4, which is going to be a second series, basically. So we're going to write a sigma. No, we're going to write the first series in sigma notation and subtract from it the other series that's also in sigma notation with the powers of 4. Okay, so that's the general idea. But again, let's just write some things down. Say you didn't get that far in the exam, you thought about the powers of 4. Okay, that's fine. Let's start by just writing the Tn for the series 1 plus 2 plus 3 plus 4, da, 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 because that would definitely be worth a mark. Okay. So when you see sigma notation, even if you don't know how to do the complete question, know that one of the things you have to do for sigma notation is find the general rule or the general formula. So for this series, our A is 1. It starts at 1. N minus 1, and then our common difference is just 1. We keep adding 1. And so that's going to be 1 plus n minus 1 times 1. Okay. Everyone with me? Do you agree with what I've got so far? A is 1. In this series, I just keep adding 1 to get the next term. So my constant difference is 1. And now I just need to simplify all of this. And that's just going to be n minus 1. So then Tn is n. Okay, cool. Tn is n. And that makes sense, right? Because if n is 1, the first term is 1. If n is 2, the second term is 2. If n is 3, the third term is 3, and so on. So for that series that we've got from 1 to 5,000, the nth term or the general rule is just n. Now we're going to do a second Tn for our powers of 4. Now powers of 4, now remember we can't go above 5,000. And because we are doing powers of 4, these numbers increase quite quickly. So 4 to the power of 1 is just 4. So you have to get your calculator out and look that you don't choose a power of 4 that's more than 5,000. So it's 4 squared, that's 16. If I go 4 to the power of 3, that's 64. 4 to the power of 4 is 256. So you keep going literally on your calculator and you just do the powers of 4. Okay, so 4 to the power of 6 is 4,096. Okay, so that's already quite close. And I guaranteed if I raise 4 to the power of 7, yeah, that gives me 16,000. I'm going to just write it here, 16,384. Okay, too big. So the powers of 4 we have to take out of this series go up to 4 to the power of 6. So 4096. Now this makes a series on its own. I'm going to write it in a different color here. So this is 4 to the power of 1. I hope you guys can see that. 4 to the power of 2, 4 to the power of 3. Okay, so what kind of a series is that? Is it arithmetic or geometric? You can tell me. Put it in the chat if you know.
It's geometric.
It's geometric, that's right. So now we're going to do Tn for this series, and that's A R n minus 1. So our A is 4. Our R, the number we multiply with each time, is also 4 because we multiply by 4 to get from 4 to the power of 1 to 4 to the power of 2 to 4 to the power of 3, n minus 1. Okay, so if you just got that far, that's already nice 2 marks in the bag. Now we just have to show how we will remove this series, the geometric one, from this series, the arithmetic one, and put that in sigma notation. So let's build the sigma. Let's start by just building the sigma notation for this geometric series, for the arithmetic series. So remember I said you have your sigma. Actually, let me make this purple. And we said a starting point. We must say where n starts. N for the geometric series in purple. Sorry, I keep mixing them up. The arithmetic series starts at n equal to 1. And where does it stop? All the way at 5,000. And what is my general term? That's n. And from that series that I've just written in sigma notation, I'm going to subtract this one, the sum of that series. So now I'm going to build my sigma for that one. Make my sigma guy over here. Where do I start? N starts, and where does it finish? Well, we worked it out. We said n must start at 4 to the power of 1. And we can't go bigger than 4 to the power of 6, so that's where it must stop. And here is my general term. Okay, and that's going to earn you another 2 marks, I'd say. It's a 4-mark question. So I would probably say this is 1 mark, this is another mark, and then 1 mark for your sigma, and 1 mark for your other sigma. Okay, Karabo, how's that?
Thank you, ma'am. That's wow. I wouldn't have known when to start with that.
Okay, but now remember what I said about if you don't know what to do, just start writing something down. Just start with, okay, the powers of 4. When I do sigma, there must be a Tn for the series. So maybe 1 or 2 marks. Because you could have gotten, I think you could have gotten definitely the arithmetic series part. And then I think also the geometric series part. Even if you maybe didn't know at the end to subtract the 2 sigmas or how to build
we could show it perfectly fine last time. Hey, Anika.
Say again, Coco?
Yeah, we could see everything. And now I have no idea why it's doing this to me.
What's wrong?
Let me just see if I can get paper up again. Okay, so we might finish a little bit later than today. Sorry.
Coco, who are you talking to? Coco, can you hear us?
Yes, sorry.
Who are you talking to?
Sorry, I'm talking to my family. I'm sorry, I'm going to mute myself. My apologies.
Okay. Right. So here is another question. 3.2, that was your other question, Karabo. Given that the following two geometric series are convergent, okay, and there's a series there and there's another series, determine the values of x for which the two series is the sum of the two series is equal to 8. Okay, so what we have to do is let's just look at each series, each of these series, and then find what R is. They're convergent. So what does that mean? Well, it's got a few implications. Remember, it converges because of the sum to infinity, and because R is smaller, then it's between -1 and 1, etc. So those are all the things that must come up in your head about convergent series. But let's just start and let's just see what is R for each of these series. So I want you to just try and work that out now. I'm going to just for each of these series, see if you can figure out what R is going to be. Okay. Does anyone have an R value for me for the first series? 1 plus x squared plus x cubed. Does anyone? Yes,
Okay.
so like x
Okay,
and minus.
yeah.
Sorry, yes, Karabo?
Oh, I was about to say the same thing. Sorry.
Okay, great. Yeah, that's it. And remember to check for your R, or to calculate your R, you check that T2 over T1 equals T3 over T2. So you literally just divide them. So you can say x over 1 for T2 over T1, and then check what is T3 over T2. So T3, the third term over the second term is x squared over x, and that's x. Okay, and if we do the other one, so I'm going to make this one blue, and then the other one, I'm going to make that one green. So same story, so it's minus x over 1 is minus x, and minus x cubed over x squared is going to give me minus x. Okay, so here our r is minus x, and for the other one we said it's x. Now, because they are convergent, we can use the sum formula, that's a over 1 minus r. And if I add the sum of the blue series and the sum of the green series together, it should equal 8. Now, for which values of x does it do that? So that's exactly what I'm going to do. I'm going to say a over 1 minus r plus, because it's the sum of the two series, and I'm going to do a over 1 minus r for the other series, and all of that must add up to 8. So there's my equation. Because I have to solve for x, I have to make an equation. So for the blue series, our a value is 1, and it's 1 minus x. I'm just going to stick to blue. Yeah.
Sorry, what the sum formula, is that the sum formula for the geometric series?
Yeah, so you'll see on your formula sheet, and I had a formula sheet up here, there's two formula for sum of a geometric series. Because this is a convergent geometric series, you can use this formula to calculate the sum. If it wasn't, if they didn't tell us that in the question up front, which kindly they do, because to try and do this with that other formula was going to get very messy.
Okay, yeah.
So because it's with this, did you try it with the other one and then it got very messy?
Yes, it did.
Yeah, that's why. Okay, so we're going to go minus x. Okay, now we've got a bit of a grade 9, grade 10 equation here to solve. So to solve this equation, it's a fractional equation. We have to multiply by the LCD, which is 1 minus x, 1 plus x. And that's basically what we're going to do now. Multiply each term with the LCD. And I hope this isn't going to be too cramped. But we do that so that we can get rid of these fractions, right? And then we're also going to multiply the 8. So you have to, because it's an equation, what you do in one place, you must do in all the places. So that means we can cancel the 1 minus x at the bottom with the 1 minus x. So that leaves us with 1 plus x. And then here we are left with 1 minus x. And that is 8, 1 minus x, 1 plus x. Okay, we've got some more algebra to do here. So this is a 6-mark question. So it is going to take some time to do, but it's okay, we've got time. Okay, so this I can see 1 minus x, 1 plus x, that is a difference of 2 squares. So I can somewhat quickly go 1 minus x squared. If you FOIL it out, you'll get the same. Okay. It's just if you recognized it as the difference of squares, brilliant. If you didn't and you FOILed it out, it would have taken a bit longer, but you will get to the same place. Okay, I'm going to take the minus 8 to the other side. And then I divide by negative 8. So that's going to make this whole side positive. And finally, we are going to take a square root on both sides. Just remember, when you take this square root, it will be positive or negative, because a square root always has 2 answers. So x can be positive or negative root 6/8. Okay, have a look. Please ask if there's anything that's confusing. It is quite an intense question. But that's what we are doing tonight. We are doing intense questions. Benedict, root 3/4. You can't actually square root square root 6 and square root 8. Remember, we are taking a square root, not dividing by 2. Any questions so far, guys? This is quite the 8. The 8 came from the question, Daneo. The 8 came from here, where it says determine the values of x for which the sum of the 2 series is equal to 8. So that's why we summed the blue series and the green series, and it must add up to 8. You're welcome. Anyone else? Oh, I see what you're saying, Nicole. Okay, sure, we can do that. Sorry, did I misunderstand? Someone else also said that. Oh, sorry, Benedict, yes. Now I see what you mean. Yes, we can simplify the fraction. The fraction can go to 3/4. Absolutely right. And then we can even go further and do plus minus root 3/2. Sorry, Benedict, I misunderstood. I thought you said the final answer is 3/4. But we can root it. Absolutely. Well done. Well done for spotting that. Also, your calculator would have told you. Okay, can we leave this one behind? Let's see what else. Now, I still don't see Christian and Hamid in the meeting. Coco, do you see Christian and Hamid? Are you here?
No, I don't see any of them. No.
Okay. Well, we'll leave them their questions then and go on to, so Yuri's here, I think. I saw her somewhere. So Yuri, you here, hey? Yes, there she is. Okay, sure. So Yuri, where was this from? What year was this? 2017. Okay. Has anyone done the 2017 paper yet? Worked through it? Anyone here? Chada's done it. Well done. Okay. So everyone, again, take a minute or so. Sola, you've also done this. Okay. Great stuff. So you can help us. You can help us work through this if you've done it already. So everyone, have a bit of a read through and just, again, think about it. Now, don't be intimidated by all this function notation. And be prepared for some function notation on Friday, because in the last few years, they've really liked asking function notation. So, yeah. So don't be intimidated by it. Just look at it and remember what it means. Okay, just think of the meaning. What does it mean? Okay, 2 more minutes just to read, maybe to strategize, to think about how you're going to answer the question. Imagine this is you on Friday and you get hit with this. What are you going to do? How are you going to approach this? What is this even about? What is this question even about? Okay. If you have any thoughts or ideas about the question, please share them in the chat. Everyone's very quiet this evening.
Ma'am?
Very serious. Yes.
Ma'am, can't we find the point of inflection finding the second derivative?
Yes. Very good. Indeed. If you know how to do it, go for it. We're gonna, in about 2 minutes, I'll go through everything with you. Okay, so first of all, this is obviously in the calculus part of the paper. So everything here has to do with calculus and a cubic graph and the derivative, etc. So we've got f of x is that function x minus 3 squared. So that's just the equation of the actual cubic graph. It's going to be cubic because we're going to square out that x minus 3 and then multiply it by x. And that is going to be give you the equation of the graph. It says that f-1 and f-3 is equal to 0. That means I've got turning points at where x is equal to 1 and x is equal to 3. Why? Because the derivative is equal to 0. So you should know it by like a mantra by now. Derive equal to 0, that's how you find the turning point. Derive equal to 0, that's the turning point. Okay. Gwandisa, Benedict, well done. You guys got 2. Carry on with the question, please, and you can listen with half an ear if you want to keep going. For those of you who are a little bit less clear on what to do, you can listen with more than half an ear. I see there's a few of you are getting the 2. Well done. That's like a 5 marks in the bag. Now this here, f of 1, means if I put 1 into my function, I get 4. So this is a coordinate point, x and y. X and y are coordinate points, and I'm going to write it down here. 1 and 4. That's a coordinate point. Okay. So let's start with this point of inflection. So first of all, we have to multiply f of x out. And that gives me x minus 3 times itself. Okay, so you'll FOIL all of that out. First do the brackets, then put the x into the brackets. So this is going to be x squared minus 6x plus 9. And then we put the x in, so that gives me x cubed minus 6x squared plus 9. Okay, so be careful that you actually squared that bracket, x minus 3 times itself, and that you didn't maybe make a mistake there already with the squaring. Now we're going to derive. That gives me 3x squared minus 12x. That's our first derivative, 3x squared minus 12x. And then we're going to do our second derivative. How do we know to do the second derivative? Point of inflection and second derivative must be together in your mind, okay? Those two go together. Nicole, you're saying 9x. Thank you. Plus 9. Okay, so that goes together. Second derivative, point of inflection, together. Okay, x cubed minus 6x squared plus 9x. Okay, now we're going to do our second derivative. That's 6x minus 12. And that we are going to put equal to 0 to find the point of inflection. At the point of inflection, concavity changes. Okay, so that's everyone happy, found x equal to 2. That is a routine question, and that's why I say if you got that right, 5 marks, nice. Okay.
Ma'am?
Yes.
But if they don't give us the x, we have to do it like that. But if they give us the x, we just put it into the fx, and then we get 2.
No, if they didn't say that x is equal to 2 and just said calculate the point of inflection, yes, then you would have to go through the whole same process and find that x is 2, and then to find the y coordinate, you write you put it into the original function. You put it into this one here.
Ma'am,
Does that answer your question, Jaden?
I mean, like if you because I just put it into the function because at x is 2, doesn't that give us the x coordinate?
So did you not work this out the way I did? Did you just sub it back in?
No, I did, but I also subbed it back in.
So you got a y coordinate as well?
Yes.
Yes, that's fine. They didn't ask for a y coordinate. They just said show, but you will most probably use it later on when you're sketching anyway. So it's probably good that you did that work already. Yeah, you didn't have to though.
Thank you, ma'am.
Okay. Okay, so 8.2. Now we have to sketch the graph of F, clearly indicating the intercepts with the axes and the turning points. Okay. Now, this part here, the turning points, those are the turning points. So they've saved you that work, actually, all that work you would have to do to calculate the turning points. Okay, so we need x-intercepts, we need a y-intercept, we need turning points, and point of inflection. So we already have the x coordinates of the turning points. We need to now go back and find y coordinates for them. We have to calculate the x-intercepts by making the graph equal to 0, so the function equal to 0. So let's start there. Let's do x-intercepts. So we take this graph here, x minus 3, x minus 3, and we put it equal to 0. So we see that we are going to have an x-intercept where x is 0 and where x is 3. My y-intercept, what is my y-intercept? If you multiply it all out, you see that it's 0. The y-intercept is 0. Turning points. Turning points, we've got x coordinates, like I said. Now we need y coordinates. So where x is 1 and x is 3, those are our turning points. So you need to work out f of 1. Oh, guess what? That's given already. It's over here. F of 1 is 4. So f of 1 is 4. So I'm going to have a turning point at 1 and 4. And now I just have to do f of 3. And guess what? F of 3 is actually an x-intercept. If you look here, x is 3 turned out to be an x-intercept, and f of 3 is also a turning point. So this is actually not as much work as you might have thought. So that's 3, 0. Okay, so there's my 2 turning points. Okay, I'm going to try and make a nice graph with this. Is anyone unclear up to this point how we got here with the x-intercepts, the y-intercepts, the turning points, etc.? Any questions? No? You're doing well? Okay, good stuff. Let's go here. Okay, so first of all, let's just make sure we've got the right shape. So this graph has a positive a value. So it's going to be like that. It's going to take that shape. So my graph is going to go through the x-axis at 0, and it's also going through the y-axis at 0. And then it's got a turning point at 1 and 4, and then again at 3 and 0. So it's going to go like this. It's going to turn. Like that. So that's 0. This is 1 and 4. This is 3 and 0. And my point of inflection is over here. Jaden, what was your y coordinate for your point of inflection? Can you share with us? You
2,
said you
ma'am.
worked it out. 2. Was it 2 and 2?
Yes.
Lovely. Okay, Karabu, no, this is Sayuri's question. How is this going so far? Is it making a bit more sense? Good. Okay, so overall, I think this was a relatively straightforward calculus question with your cubic graph as far as it goes. It's likely going to turn up now in complexity. So let's see, for which values of x will y equal to negative f of x be concave down? What does that mean? Concave down. Concave up and concave down.
Isn't it the minimum, the
So the minimum and the maximum, that's got to do with your turning points, because this graph will have at 1 and 4, it will have a maximum over here, and this will be a minimum. But what does it mean, concave down, concave up? Yes, you use the point of inflection, absolutely. Concavity has to do with the bending of the graph, which way it bends. Is it bending downwards or is it bending upwards? And this graph's concavity changes at the point 2 and 2. It bends the other way. But this question is asking about y equal to minus f of x. What do we do when we change that, when we make it minus f of x? What do we do to the graph when we change it in this way? Does anyone know? Who wants to try this here?
Do you reflect it, ma'am?
Yes, you reflect it. Well done, Zwelikle. How? What kind of a reflection is it?
About the x-axis, I think.
Yes, it's about the x-axis. Well done. So this shows a reflection in the x-axis. Okay. Now, what does that mean for concavity? If it reflects in the x-axis, we're basically taking this graph and turning it upside down. We're just going to go zoom. So if this graph is concave up before this point 2 and 2, then it will be concave down before the point 2 and 2, because we're going to literally just flip everything around. So for which values of x will this graph be concave down? So what's going to happen to my point of inflection, 2 and 2? I mean, you don't have to do this like I'm doing it now, but it will basically look something like that. You can do it. It's a 2-mark question. I'm explaining, spending a bit of time on it, but you don't have to. So this is going to, because we're reflecting in the x, y becomes negative. So it's literally just going to do that. And now where is it going to be concave down? Do you guys know how to tell concavity when it's concave down and concave up? Do I need to go over that? Please just give an indication if I need to go over how to know if it's concave up or concave down.
Yes, ma'am.
Okay, so basically you take your ruler and you put it tangent to the graph. And if the graph is above your ruler, then it is concave up. And if you move it along the graph, and you'll see at the point of concavity, it flips over, it changes, and you'll see that it becomes concave down. So it's for all the x's greater than 2 over here from this point on. So x greater than 2. Okay, now 8.4, I'm just going to write this here, x greater than 2. Use your graph to answer the following questions. Determine the coordinates of the local maximum of h if h of x is f of x minus 2 plus 3. So Sola, with the, are you asking about the concavity? I wish I could show you with the ruler. Okay, how can I do this with a, I can do it with a line. Okay, let's do this. Let me show you. Okay, so imagine this line. I'm just going to change the color. No. Let's make it black. No. Let's make it something else. Let's make it red. Okay, so imagine this is your ruler, and you literally take your ruler and you put it like on the graph like that. Like that. And then you move it along the graph. I'm going to try and do it. Doesn't quite work with my screen. Oops. And you move it along like this. Oops. Bending it. Yeah. Okay. You move it along. The bending thing in as well. Okay. There we go. That's what I wanted to do. Okay. And you turn it. It's really difficult with this, but anyway, so say you turn it and you'll see the whole way up to this point where the point of inflection is. Sorry guys, this isn't working for me right now. Let me try again with a different color. Okay. And you move your ruler along, if you've drawn the graph, actually, you'll see that. So as you come from that side, the way I did now, and you move it along your graph, you'll see that it is concave up from the point from before x is 2. But when you get to x is equal to 2, and it's concave up because the graph is above your ruler, it's about how the graph bends. And then if you move it like this, maybe this is not, you see there, after that point, it goes below your ruler. Then it becomes concave down. Okay, but if you take a ruler and you do it, you'll see what I mean. If you move it along and the graph is above your ruler, it is concave, concave up. If you move it along, and as soon as you go past the point of inflection, you'll see with your ruler, then it's below your ruler, and that makes it concave down. Okay, let's move on to this last question so that we can hopefully finish not too late. So determine the coordinates of the local maximum of h if h of x is f of x minus 2 plus 3. So what have we done? We've subtracted from the x's. So our usual graph, our normal graph, the one that we've been working with the whole time, the original graph, is f of x. Now we have subtracted from the x's, which means a horizontal shift. We're shifting it left or we're shifting it right. If we're subtracting, what do we do? And remember that it's always counterintuitive. We are shifting the graph 2 units to the right. Horizontal shift to the right. Okay, that arrow means that way, in the right direction. What does this mean? This means a vertical shift. And it is asking for a local maximum. So we already said, I'm going to have a local maximum over here. Now, if I move the graph 2 units to the right and 3 units up, this point is going to change. So I'm going to move it 2 units to the right. I'm going to rub this out to make space. So you don't have to work out a whole long equation or anything. You just do it knowing your shifts. So 2 units to the right and 3 units up. And what is that going to do to this coordinate point? It's going to increase the x to 3 and the y to 7. So your new coordinate point for your local maximum is going to be 3 and 7. Nicole says, the best way I remember concavity is when the curve is facing up, it is concave up, and when the curve is facing down, it's concave down. That's it. It's about bending. Yeah, so maybe not so much about facing up, but how the curve is bending. But yeah, that's a good way to remember it. Thanks, Claire, Nicole. Claire is in the question, and she claims that f-2 is equal to 1, meaning she's saying that there's a turning point at 2. Is that right? No. No, we've said that there isn't a turning point at 2. The turning points are at 1 and 4 and 3 and 0. So you can just write something sensical here about no, you do not agree with Claire because there isn't a turning point. Okay. Okay, so Yuri, I am sorry we didn't get all the way to question 9. And there was another question 9. But I'll ask Lee to do them with you tomorrow night. So I won't see you guys again before you write your exam. So I just want to say best wishes to all of you. And I'll be thinking of you. And I know you're going to crush it. And then you've got next year to look forward to, and I hope your future plans are bright and amazing. Thanks so much, everybody. Before we go, please ask a question if you still have something that you're wondering about. Thanks, guys, and thanks so much. Yes.
Ma'am, can you please explain the last question quickly again, please?
So this says that f of 2 is at the derivative. Sorry. Yeah, so there's no turning point at, so it says that at the f-2, the derivative is equal to 1. But no, we said that that's not the case. We've got the turning points here, 1 and 4 and 3 and 0. Okay. Anything else,
Thank you, ma'am.
guys? Okay. Okay, remember tomorrow night you've got Lee for another session, and then Saturday probably is going to be paper 2 focus. Not probably, definitely, because on Friday it's all done with paper 1. Good luck, guys. Good luck.
I feel like an hour is too short. Hey, Marlies. I don't think it's enough.
Tired? You can keep going if you want.
I don't know. That's okay. I'm just the mentor here. I don't want to overstep, but
No,
thank you guys
that's
so much for thank you guys so much for joining us. I've got my own teenager over here. He's in grade 8. He's also writing a cycle test, and him and all his friends are here pressuring me for questions. So I'm gonna have to go help them out as well. But thanks so much for joining us, guys. Remember, join us again tomorrow. We're going to be continuing. I think Marlies, some of these questions we can pass over to Lee, and she might see if she can tackle them tomorrow. Yeah, and she'll be able to do all of those for us. But thanks so much, guys. We will see you all tomorrow at 6 p.m.
Bye, everybody. Everyone.